Hello everyone. My name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. Today, we will learn how to analyze protein-ligand interactions and protein-protein interactions. I covered already this tutorial, but then I realized that I covered it in kind of pieces. So today, I am going to streamline it into a very good way. Okay, another thing, today we will cover this tutorial with a very basic possible way. Uh, and because I want that everyone can capture it. I know most of my viewers are not directly from the bioinformatics. They are working in some agriculture sciences, biochemistry, molecular biology, microbiology, and biotechnology, those kinds of fields. So they are not so much directly aware of many things. So therefore, I'm making this tutorial just on the possible uh, beginner level, but don't worry, it is quite professional and you can use this tutorial for your publications. Okay, so let's start. What are the learning tasks in this tutorial? As I told you, I will use the easiest possible way to give you a push. Okay. In today's tutorial, I will use a PDB structure 3MTN. Why I will use this uh, PDB structure? Because this tutorial also contains ligands and also it contains protein chains. So we will have a chance or we will have a luxury to use this structure for calculating the ligand interactions and also for calculating the interaction between different proteins, protein chains. In other words, I should say. Okay. I'm sure maybe you will ask me later that if I modeled my protein with another protein or if I docked my protein with another protein, so can I use this tutorial? Yeah, sure. Because whenever you dock it or you model it, whatever you say, uh, the structure will contain different chains. One will be your protein, and or I would say the query protein, and the other will be the target protein you docked with it. So possibly one will be chain A or other will be chain B. Okay. Then finally, you can also stop there. But if you want to generate a stunning visualization for your manuscript and thesis, we will also proceed towards PyMol. Okay. So first of all, this is the basic program, and I'm sure many of my user will be aware of, or many of my viewers actually they will be aware of. Okay, so the program name is Ligplot Plus. Initially, this program was designed for the analysis of protein and ligand pictures interpretation in all those things or analysis, but later on, two other versions or two other modules were incorporated in this program. So one is the antibody interaction, one is the protein-protein interaction, and the other is the oldest one, the lig plot. I mean the ligand or the ligand plot. Okay, this is the official website. If your internet is not good and you are not seeing it well, so I would suggest just type Ligplot Plus in your browser and it will lead you to this website ebi.ac.uk slash thornton dot dash srv. Okay, then you will see this kind of screen and they will ask you for an email address and a password. So if you have an account already, then there is no problem. Just sign in and use it. We will use it. Or you can download it. But if you don't have, then you have to click here the academic license You will receive a kind of form or pro forma, just fill it. But remember, you cannot use your personal email there because they are not giving license to the personal users, just like gmail.com, outlook.com, yahoo.com, or hotmail.com, lio.com. These are personal accounts. Or if you have qq.com or 163.com, or if there are any others, so they all comes in the domain of personal account. So this program will not give you a license for personal account. And remember, the license is free, so don't worry. So what you will need, what kind of email address then you will need? The email address you will need will be your educational email address. Use the email address of your university. Just like, for example, you are working in some, let's say, you are studying in the um, let's say Xiamen. Okay, I been their website, so I named this university. So their email address will be like this: your name or maybe your student ID, then at the rate xmu.edu.cn. If you are in India, then it will be the university abbreviation, then .edu.in. If you are in US, it will be the university abbreviation dot then possibly edu or maybe no edu but then dot US. So these all are or if you are in Pakistan or in Bangladesh or other countries, so use the email address the university provided to you. I'm sure most of the university provides the email address to all the students and faculty. So, on a lighter note, if you don't have this email address, you can use the email address of your another person, another friend. But be sure in that case, you are not going to use it for commercial purposes. You will make problems for that friend or teacher. You use the email address of. Okay. So once you fill that form with your institutional address, submit it, you will receive a download link, and then you can download a smaller program. You can install that smaller program into your computer, and that's it. Remember, this license you have will be valid for 1 year. Today is March 6th. So if you got it today, it will be valid until March 6, 2026 for 1 year. Okay? So this way you can renew it again and again after 1 year. That will not be a problem. But believe me, it's a very uh, classical and standard program, and you will not you will be amazed that even today the latest programs they are using Ligplot for their analysis. Okay, so I hope I clear this point. Okay, now let's start. Okay, so first of all, I'm going to show you the structure I will use today. So I'm going to open my PyMol. I open my PyMol and the structure which I already downloaded here is the structure 3mpn download files, then PDB format. I already downloaded, so I will load it directly from my download folder and it will be here 3mtn, and now we have the structure open. Okay, so now I'm going to color it by chain, so you will see it. Okay, color by chain. Okay, now you can see four different colors. Actually, this is a dimeric structure and two proteins. One, the smaller one is ubiquitin, and the larger one, I didn't focus which one is this. So it's okay. So You can see this is one chain, the green one, the cyan is B chain, this magenta is C chain, and this yellow one is D chain. If you want to know which chain is which one, so you can just click here and display sequence. Now you can see this is A chain and this is the green one. Then this is B chain, the cyan one. You can see from the color also the sequence will take the same color, and here you can see chain B. The magenta is when from where it starts, it is called C chain. You can read here this one, the bigger one. And then the yellow one, you can see the D chain. So in today's tutorial, I will teach you how we can or how you can monitor or analyze that what are those residues which are interacting between this A chain and B chain. Uh, and the H and C chain are a bit far away. I don't know, but probably the B chain and C chain are interacting, but that's okay. I will teach you just this one, the B chain between the A and B. Okay, we have different ligands, just like we have zinc in the structure. Possibly this one is zinc one. Okay, wait, let me. Which one is this? This is the chlorine. Okay, so we have also the chlorine and we have also zinc in the structure, and possibly in your case maybe you have your ligand, just say a drug molecule or any organic molecule. So that doesn't matter, ligands are ligand. My task is just to teach you how you will analyze. Okay, so this is your structure. Now what you need to do, just uh, the program I installed is in my D directory and I keep it in Ligplot, Lig plus. Okay, this is the program. Okay, when you install it, you may not see these so many files because I brought them here. And okay, so what you need to do first, remember, to use this program easily, just you need to click here, the download, copy the structure, copy. I already copied, so that's why, okay, no problem. I will copy it again into the same folder, like plus. Okay, it's here, 3MTN. It's already present. Okay, now you will see this icon because Lick Plus or Lick Plot is basically run with it's a jar file, or it works with the Java. Okay, so normally most of the system, your system, my system, it comes with a built-in Java, so it will not be an issue in your system. Just click here. But if you see, let me tell you, if you see ligplus.jar, but if the icon is not this one, let me make it bigger if I can. If you if you see the Okay, possibly I cannot make it bigger than this. If you can see this icon, just a kind of cup with some fires. This is the icon of Java. So if you are seeing this, it means your system has a Java. If you are not seeing this, so before to ask me in the comment section, I would suggest to just install Java into your system and it will be fixed. Okay, now once you click here for the first time, if you have Pymol installed, so just click here, edit and program path. You can see Pymol executable. I gave it to executable to my Pymol. You can do this. If Pymol is not installed, just it's okay. If you have Resmol installed, you can give the execute the location here. This program will automatically fix the Pymol for in your case or in my case, whatever you should say. Okay. Okay, now it's very easy to use. First click file, then open. PDB. Now browse, you will see nothing. Then in file types, click here and say all file, or you should say PDB files. So now you are seeing all the PDB files present in this directory. Our structure name is 3mtn. Click here, 3mtn. Okay. Now you can see it tells you about your structure, that the structure you provided me, it contains four protein chains A, B, C, D. I already gave to you the demonstration. What are those four chains? It will also tells you that it contains two ligands and six metal ions and 43 water molecules. Okay. So the ligand that is comes from the X-ray crystallography, that is glycerol in this case. Okay, maybe in your case you have your own ligand, you will see it here. Okay, these are the ions, zinc chloride and chlorine, zinc and chloride ions. Okay, now let's say this is my ligand, zinc. Okay, so click here and I want to see how many or what residues are interacting with this ligand. Remember, you are seeing Ligplot, you are seeing Dimplot, and you are seeing antibody. If you are interested to analyze the protein ligand interaction interacting residue, click the link plot. Okay. If you are interested to analyze the protein interaction, then click dim plot. So first we will use the link plot. Let's say this zinc is my what to say, is my ligand, is my drug, whatever you say. So just click here and click run. Now you are seeing here like from chain A, cysteine 384, from chain A, cysteine 387, from chain A, cysteine 440, and from chain A, cysteine 437. So one thing is clear, only the cysteine, only the cysteine residues are making a tetrahedral complex with this uh, zinc ion. Okay, you can also change these names. Let's say you want this name here, bring it here, just click it. You want this name here, you want this here. Okay, you want this here. It's very easy. Now you can take a screenshot and whatever, you can also save it directly, export it into a PDF. And okay, now if your PyMol is connected, my PyMol is sometime giving some error. So let's see what it will say this time. Okay, now you can see automatically it extracted only those residues. Now you can, I have some beautiful tutorials about how to change this background color, make it white, how to make the spear scale, like this is the spear scale. If you want to make it smaller, so I will drop those link in the description section of the tutorial, so you can uh, generate a very beautiful figure pictures for yourself using the PyMol directly. But okay, so with this was all about how to say, okay, excuse me. This was all about the how to study the interaction of the ligands. Now click file, open. Now I'm going to replace again replace another structure or the same structure. Now we are going to study the dim plot feature. Okay, in dim plot feature, for example, you want to study, let's say close this one. Okay, okay. In dim plot feature, you want to study the chain A and chain B. So you have two options. Just ask the program, give me the interaction between chain A and chain B. Another option is to identify the residue like from this location and then this location. Okay, for that is easy. Just check from here, like from which range of residues are these one, or which range of residues are these one. But if you are new, or if you are using for the first time Ligplot, I would suggest just go simply and ask the program this like this way. Uh, okay, chain A and chain B. Just click here. So it will, and click run. It will do rest of the job. Okay, but if you are interested, let's say you are interested in from chain A, from residue 20 to dash residue 40, then chain A, and again residue 30, residue 50, chain B. You can do this one. But if your residues are 20 to 40, chain A, and then also you will use this, and from 100 to 110, chain A. You can also write like this. If you want to include water, just click here. If you don't want to include water, just uncheck this. Okay, so I I'm not going to use this thing. I taught you how you will use this thing. So simply, if you are a beginner and if you are interested between chain A and chain B, click here and click run. Now, once you click run, it will take some time, and you can see now, see, make it bigger. Now, the green one, sorry, the blue one are chain A. You can see here clearly chain A, okay? And the interactions, if you can see, let me make it bigger, okay? Okay, this is arginine from chain B, and this is histidine from chain A, 510 histidine and 74 arginine. As the interaction is taking place between the positive and the, okay, both are positive. Okay, so the interaction is taking place between the Ne2 and the oxygen, the carbonyl oxygen of the C-terminal carbonyl oxygen. This is, if you know the amino acid structure, this is carbon alpha, this is the nitrogen, then this one is the carbonyl group, and this one is the oxygen of the carbonyl group. So now, and if you see here, it shows you 2.91. That means that this interaction is taking place with the distance of 2.91 angstrom. Okay, what are these things, these eyelashes kind of things? These are the residues which provide the hydrophobic interactions. You can see, when I move this, so the below at the bottom, this one is also moving because they are interacting, or they are providing the van der Waal interaction or the hydrophobic interactions. Okay, and what are those residues? You can read here: phenyl 466 of chain A and leucine 71 of chain B. Okay, so now from here you can see what residues are interacting. Now, once again, you can directly click Pymol here, and sometime the Pymol will produce some troubles to you. So that is not a worry. Just save this picture with yourself. You have the idea like which atom. This picture will give you the idea like which atom of which amino acid is interacting. Okay. Now, what you will need to do, I will also drop another link of my video. Let me show you, like if you have this figure, now you want to save this figure, and now you want to generate this figure, this picture in the PyMol, then let me show you in my YouTube channel, you already have. Here is the video. Calculate atom distance in pi mole. So using that picture, information of that picture, you watch this video, you will understand how we can use that information and create stunning images or stunning pictures. Okay, I hope you will be able to analyze your and protein complex and protein ligand complexes from now on. If you have any question which I did not cover in this video, please ask me in the comment section. Okay, and if you have not subscribed this channel, please subscribe it. uh, we in future we are planning to continue this journey, and I hope I will bring interesting tutorial, just like today was the beginner level tutorial, but I also sometimes cover the advanced level of tutorial. So if you don't want to miss it, just also turn on the subscription, the bell icon button, that you should know. Okay, uh, that's it for now. Thank you. And if you're liking my video, thumbs up. Okay, thank you. Bye bye.